Hello?
Hello. Hi. Sorry. Can you hear me?
Yes, can you hear me?
Yeah, I can hear you.
Awesome.
Okay. So my name's Devin. Um,
Hi, Devin.
and yeah, hello. I'm looking too bright.
How are
Okay.
you?
I'm good. How are you?
I'm good. I'm good. So, your mom sent me all of your exam stuff. So I'm just gonna go ahead and use that and explain the stuff that you weren't able to answer correctly.
Yeah.
Is that okay?
Yeah, that's okay. Okay. So which one did you want to do first?
We're gonna start with the combustion reactions,
Okay.
right? Okay. So let's do this. Okay, so I'm sure you've heard this in class a million times. Hope maybe.
Yeah.
But for some reason on that test that you took, it was something that you still kind of struggled with. What do you
Yeah.
think happened there?
Um, I think I think what happened was some of them looked the same, and then for some of them I might have not fully like put like carbon dioxide. I might have just put like carbon or something like that. And also for like I know one of the questions is like what order do you like the Bunsen like that?
Yeah,
And I think I got the yeah, and I got the order wrong for that one.
okay. So, okay. All right. So I'm going to make this really simple for you, right? So these combustion reactions, they release a lot of energy, right?
Yeah.
Um, in a common combustion reaction, you have a lot of hydrocarbons combinations, right? Containing
Yeah.
compounds reacting with specifically oxygen. So primarily the two products you will see in a combustion reaction is going to be carbon dioxide and water, no matter what happens, your end product is going to be um, this carbon dioxide and water, right? And your
Yeah.
react these are your the products, meaning this is what happened after, right? This is what you get after doing the reaction, right?
Yeah.
And then your reactants usually is on the left side, right? These are your reactants. Sorry, I'm really bad at this
That's
um,
okay.
drawing stuff, but I think I'm just gonna write it out. The reactants is going to be on your left side, right? And no matter what happens on your reactant side, you're going to always have oxygen. Whatever element you're combining with oxygen is going to release carbon dioxide and water. Okay.
Yeah.
And I'm going to show you an example of that so that it makes sense to you. But then also, in addition to this stuff, right, in addition to this combustion reaction, and I'm sure this is something that you guys went over, whenever you guys do, whenever you do produce or have these products of carbon and oxygen, you also have to kind of balance out the equation to make sure that you have enough carbons and hydrogen and oxygen on the left side and on the right side. Because technically, the the three elements that you're dealing with here are carbon, hydrogen, oxygen. That's it.
Yeah.
And your products is always going to be carbon dioxide, and it's always going to be oxygen on as your reactant. And I'm saying that because I noticed on your exam that there was a question about what is the reactant, right? The answer there should have been oxygen,
Okay.
right? And then the other ones were
Yeah.
what were the products, and the answer there should have been carbon dioxide and water.
Okay.
Okay.
Yeah, I know which ones you're talking about.
So when I say, you know, you can modify the reactants and you will still always get, sorry, what is this? How did I get rid of this? Okay, you will still always get the carbon dioxide in the water. And I say that if you had sulfur, or if you had nitrogen, right? You will,
Yeah.
if you're, you can predict the combustion reaction as long as your other reactant is going to be oxygen, right? So if it was sulfur
Yeah.
plus oxygen, then it's going to be like here in this case, when we did the reaction, it was just carbon plus oxygen, right? So that gave you carbon dioxide. Now, if it was sulfur plus oxygen, then I will give you sulfur oxide,
Yeah.
right? So it's, you just have to follow the element. Does that make sense?
Yeah.
Do you think you can explain it to me?
Yeah.
Okay.
Okay. So let's see. So with
So
let's see.
let me go to the next page. If I
Okay.
ask you on this example that we have here, if I asked you to perform this reaction, what would you get?
Okay. So it's CH is, I believe CH is, not CH is.
So I'll write it out when you tell me. What should I put here?
So we do right. So it's CH3
Okay, CH3.
plus.
Just
Wait, yeah. So CH3 plus OH.
CaCOH, just OH for here, plus what?
Oh, then it's plus.
This is
What is
this is your reactant part side, okay? Just remember that.
plus? Okay, so it's plus 2.
What reactant do you always have to have?
Oh, you always need oxygen.
Yes, so you would add oxygen here, right?
Yeah.
In order to make the reaction work. Let's see, what did I do? Always does this, sorry. Okay, here we go. Oh no. Okay. So I'm just gonna say it. CH3OH plus O2. Now, if you combine this reaction, what would you get?
You would get. I think it's. What would you get? You would get.
What's your product? What is it that what is the product that you always get when you do a
You
combustion?
get car. You would get carbon, which is. I think it's C.
Uh-huh.
And it would be C. Is it C? Is it C2?
See,
Or
carbon dioxide, right? There's
yeah.
a carbon and two oxygens, CO2. And this is something that you breathe out. This is like you inhale oxygen and you exhale carbon dioxide because that's toxic to your body, right?
Yeah.
But carbon dioxide is something that has to be released when vapors happens, when heat dissipate. Does that make sense?
Yeah.
Yeah, I'm glad that I'm walking you through this like this because it helps me know if you're you're getting what I'm saying, right? So the simple answer to this question is your result is always going to be CO2 and water, okay? At the end of this reaction, heat has to be released to something in the environment, right?
Yeah.
That is your carbon dioxide and your water. And it essentially gets released to that because those are the gases that the environment can deal with, right? Water can go back to can be reused, and carbon dioxide we need for air,
Yeah.
right? So what's the last product here?
So the last product would be H2O.
Yes, H2O. Perfect. And do you get that now? Does that make sense to you?
Yeah.
Will you get this wrong?
Probably not. Not like you explained it to me that way.
So the thing is, from what I understand from your parents or from your mom and your dad, you're gonna have like a verbal exam on this, right?
Yeah.
Right. So because I think they told me that he is giving you another opportunity to review the test.
Yeah. Yeah.
Right. Okay. So I'm doing this with you, and I'm hoping that you're able to verbalize what I'm teaching, so that whenever you do the exam, you can essentially just let him know, like, hey, this is what I understand about combustion reactions, right? They tend to release heat, a lot of heat, because you're burning hydrocarbon, it vaporizes and it goes into carbon dioxide and water, right? And that's always going to be the product, right? So, and I think the only thing that I didn't say here is, I don't know if you guys are doing this in class. After you draw the reaction, usually you have to balance this out, okay? I'm not sure that that's something that you guys are doing yet.
Yeah. I don't think we're doing that yet.
No, you're not balancing equations yet. Well, at some point we'll get there.
Okay.
Okay, now we're gonna move on to some of the things that I also saw in what you guys were doing in class, is you guys are discussing these different types of flames that are involved in a candle. And you've never thought a candle so complicated until you took chemistry.
Yeah.
And so some of the things I kind of like wrote out some of the questions that you were asked, but I wanted to just like kind of, give you an overview. Like, you have this brightness of the flame, right? And the candle itself is made out of paraffin or petroleum wax. And usually in chemistry, you talk about paraffin, but paraffin is made out of carbon and hydrogen. Everything that we have been talking about, combustion reaction. Candle flame is just an example of um, a incomplete and a complete combustion reaction. Okay,
Yeah.
and candle is just a very easy example of the whole principle, right?
Yeah.
So now, like I said, it's just an example of hydrocarbon combination. And some of the question that I saw in your test was, how does the solid fluid get to the tip of the wick? What causes the yellow part of the flame? Where specifically in the candle flame does the carbon come from that reacts with O2 to make CO2? And then now write out the incomplete combustion reaction formula for an incomplete combustion reaction, right? So here's the deal. When you're thinking about a candle, the heat of the candle, I think when I read some of your answer, you kind of have like the general idea of it, but there was just a little bit of things that you could have kind of switched a little that I noticed, because you did say something about like, the flame melts to the top, the solid fuel. I saw that. But the thing is, what happens is the liquid fuel then moves up through the wick. And I think you said that as well, which is what you said, like a capillary action.
Yeah,
And the fluid and the wick is just the cord, right? The stick, right? And
yeah,
that is kind of like the form of communication between the wax, the candle, and the flame, right?
yeah,
Well, the thing about it is the liquid fuel, once the flame is there and it's burning the wax, it becomes liquid fuel, and then it vaporizes. Now this is when now we're talking about the actual example of the combustion reaction. Like it vaporizes to burn within the candle flame. That is why, that is how the solid fuel gets to the tip of the wick. It's because of the vapor, right? And I think you said something along the lines in that, and I saw that he like kind of checked everything, and then there was that one X, and I think that was because
yeah,
he was looking for the vaporized part.
yeah,
Like he was looking for like, where's the gas? Because I have given you solid and liquid. You have given solid, liquid. Was the last transformation of the element, which is gas, which is the vapor that helps the candle burn,
yeah,
right? Okay, does that make sense?
yeah,
Okay, will you explain it that way to him?
yeah, I can.
Also, another thing I saw on the on your paper is that there's this, you guys had a lecture about the brightness of the flame or lecture.
Yeah, it was, yeah, it was like a video that they put on for the whole class to watch.
Oh, it was the video.
Yeah.
Oh, okay, did that help?
Yeah, it helped. But like the video, it wasn't um it wasn't written like modernly. It was written like 150 years ago. So like all like the words that they were saying kind of didn't make a lot of sense.
Okay, okay, all right. um So another thing that I'm kind of sensing here is you're still kind of learning the best way that you learn, right? And it sounds
Yeah.
like listening to 100-year-old visual video is not one of them.
Yeah.
I'm hoping that I can make this visual for you and I can simplify things for you so that you can understand that this is really just simple concept that is, essentially the main point is a part of your life. Chemistry is part of your life. Having a
Yeah.
candle, carbon dioxide, which you breathe out, oxygen that you breathe in, all of this becomes a transformation that then we use in exchange, right? If you are burning a candle, right? Where do you think those
Yeah.
elements go? Right. So I'm hoping that
So
I make that interesting for you.
yeah.
Okay. So
And
another,
like
okay, go ahead. You can ask the question.
okay, so um I know you have it listed as number two, says what causes the yellow part flame. I put
Mhm.
down, and like I don't know like kind of what I got wrong, but I think I know what I got wrong. I put down, if the flame is yellow, that means there's not enough oxygen or fuel and it's considered incomplete combustion.
Mhm.
So I was thinking that um I was thinking that I know I didn't do that wrong because it got marked wrong for two things. So I think what I didn't say was um the yellow part of the flame is caused by incomplete combustion, and incomplete combustion is when there is not enough fuel to have the flame be like a perfect blue. I think it is like perfect. Yeah, I think a perfect blue. Is that what I should
Yeah.
have said?
So you're right about like the red, orange, yellow flame is essentially like incomplete combustion of gas, right? But the candle flame is generally yellow because of the presence of unburned carbon particles, right? Because the carbon is coming from essentially the paraffin wax, right? So
Yeah.
when light falls on these particles, they scatter yellow color. They show that the combustion of hydrocarbon is present in a wax or a candle is not complete. Okay. So it's just, it means you should, I mean, I think you should have gotten partial credit for that, but essentially it's just the fact that there's presence of unburned carbon particles. Does that make sense?
Yeah, that makes sense now.
Okay, and then number 3 is where specifically in the candle flame does the carbon come from that reacts with O2 to make CO2? Right? So I think, you know, we've been talking about this, but you know, obviously we'll talk about it a lot more. Is, you know, candle wax, as I said earlier, is a mixture of hydrocarbon, right? I'm gonna keep saying it until it sticks. I'm gonna sound like a broken radio, but it's a hydrocarbon, right? And the general formula is CH whatever. It could be CH50, H40 something, right? You know, N is that's a lot. Like modern ones are generally low molecular weight polythene. Like, yeah, when you're the first the wax has to melt, right? Then the liquid has to travel up the wick. I'm saying this again so that you can tell it to him, right? You know, it melts and then the liquid travels up the wick by the capillary action. Then it gives off the vapor. The vapor has to mix with the surrounding air to give it a flammable mixture, right? Then it requires an input of energy, usually by radiant heat from the flame, right? To initiate a free radical reaction where oxygen atoms are produced, which strip off hydrogen to create OH radicals, which strip off further H to make H2O. So it's like a balance. It's essentially that equation, and I hate that they haven't talked about this, but it's this principle called like Le Chatelet's principle, where if you have too much oxygen, the equation will move towards the reactant and start making that. And then if you have too much reactant, then they'll move to the right side and start making more oxygen and carbon dioxide, right? So, to answer this question, where specifically in the candle flame does, wait, what? Where specifically in the candle flame? Did I write this wrong? Where specifically in the candle flame does the carbon come from?
I think
Oh,
it's I think you just have to switch the and does. I'm reading it. It says where specifically in the candle flame does the carbon come from that reacts with O2 to make CO2?
okay.
Okay.
And essentially it comes from the wax. It comes from the exothermic process that happens when temperature increases until particles of the carbon glow
Okay.
yellow, you know.
Yeah.
And that is why candle emits light and hydrogen doesn't, because it's essentially the gas and the temperature breaks the carbon bonds to make the carbon dioxide, the carbon monoxide, right? So
Yeah.
does that make sense?
Yeah.
So essentially it's like the breaking apart of that hydrocarbon is specifically where the flame comes from, right?
Yeah.
It's like the breaking down of that energy. and what helps that breaking apart of carbon dioxide of carbon is essentially the oxygen atoms, right? The oxygen atoms, when they're kind of like in like by themselves, they become like what they call free radicals, and they become like very strong and can break down things. It can break down, obviously this carbon bonds, but it can, in a medical perspective, it can break down bacteria. Like people get sick when free radicals are not, when free radicals exist, because they break down things. They call it like superoxide mutase or whatever. Like kids that are born without like a certain enzyme, like this one. I mean, I'm just relating it, but it's not like, I'm just kind of making it more real for you, like how important these molecules are. And in this case, the oxygen is helping break the carbon bonds to make carbon dioxide, right? And that all ends up, and that all happens because there's a combination of oxygen and heat, right, together. And that increase in temperature leads to the oxygen working with heat to break down carbon bonds. And essentially, when that temperature is increased until you see that glow, that yellow glow. Does that make sense?
Yeah, that makes sense.
Okay. And then another thing that I saw was he had asked you for the incomplete combustion formula
Yeah.
products for incomplete combustion, right? And I kind of just went ahead and put this up for you, right? Because these are the formulas for complete and incomplete combustion, right? Because on the very first of the page, the complete combustion was the first one you got wrong. And now you'll never forget that a complete combustion produces carbon dioxide and water, right? Now in an incomplete combustion, right, you just add more carbon
Yeah.
and more water.
Okay.
And that's just
Yeah.
that just, you know what that means? Remember I told you that the reason why the candle flame is that like it's that combination of oxygen and the breaking down of the carbon bond. This is telling you, this two carbon is telling you that they have not broken that bond. It's incomplete.
Yeah. So it's the unburned carbon particles, like you said.
Yes.
Okay.
And that's why, and I don't know if this will connect to you, and that's why the yellow color is incomplete. Because the unborn, the unburned carbon is literally like right there, right here.
Yeah.
Does that make sense?
Yeah, that makes sense.
Hopefully this makes sense a lot. It's right here. This is the unburned carbon, unburned, and hence gives you light, right?
Yeah.
What are you, can I ask you a question?
Yeah.
What are you wanting to go into in the future?
I was probably thinking about like being maybe an architect or working like as an engineer.
Nice. Okay. Okay. All right. Well, that's awesome.
Yeah.
100% awesome. He's smarter than me. One day. And just as a side note, we don't all get good at this overnight.
Yeah.
Yeah. You gotta get through all this stuff right now.
Yeah.
Let me just get through. I don't know why. Sorry, one second. My computer is messing up. I don't know why. You just did that. Can you see my screen?
It just went all black.
It did? Oh my God, what is happening? I don't know why it did that. Well, I think I had to open up the, okay. All right, so since we talked about that now, I think there was also part of your test where your teacher was asking you, like, what is the hottest part of the candle?
Yeah. And I said it's the halo, which is like it shows right here. It's like the top part of the flame, which is like I think it's like the brightest part too. I'm not sure.
Why did he mark you wrong on that one?
Um, I don't know. It says okay. So it says explain what causes the particular part of the candle flame to be so hot, or explain how you can show. I don't know. I said because I tried to do the first one. I said the halo is the hottest part of the flame, and I think you can see like a picture of the candle I drew, and I kind of like dashed it off, and I just kind of wrote that there.
Okay, I don't, maybe next time just say like the outermost zone or halo,
Okay.
just like parentheses, halo, whatever you want to call it. The outermost zone is the hottest part of the candle. And I think he just wanted you to quickly explain why, right? Because he's no longer kind of, I mean, he's no longer kind of talking about like the yellow color, because the yellow color is the middle zone, right? That
Yeah.
represents complete combustion, and then therefore the unburned carbon. But the outermost zone, which is the hottest part, that tells you like it is blue color, right? Here you can represent the complete combustion takes place. Why? Because there's good amount of supply of oxygen, literally.
Yeah.
Does that make sense? So when
Yeah.
you,
I'm just gonna write down like just I'm gonna write down what like the little bullet points you have or things.
yeah, just you can draw that and just say that, and then the hottest part of the flame represent complete combustion, and that takes place due to good supply of oxygen.
Okay. Okay.
Okay. And I'm not sure what I mean, obviously, if he asks you something else, because he'll probably ask you something different because he already asked you the hottest area. So he'll probably like, what is the moderately hot area?
Yeah.
And you'll just say the yellow area, the moderately hot middle zone, which is the yellow area, the incomplete combustion. And then if he asks you what is the least hot, you'll say the dark zone. Why? Because of the formation of vapor takes place in this region, right?
Okay.
No
Yeah.
combustion takes place there.
Okay.
Take note of all of that. Matter of fact, let me just put it on the chat so that you can take note of it. How do I get to the chat? Okay. Chat. Okay. I'm gonna just say this. Outer zone, outermost zone. I don't know if you want to copy and paste it somewhere. Hottest part of. Okay. Oops. Yes. Why does it keep going blank? Okay. Something's really wrong. 1 second. Okay. Did you see that, what I sent in the chat?
I cannot.
Can you see that?
Oh yeah, now I can.
Okay. So I put it in the chat what the outermost zone means. I might have spelled it a little bit wrong, but just, and then I'll write down the middle zone too, because I think he might ask you that, just kind of fair game.
Yeah.
Moderately hot. It is yellow in color. Here, incomplete combustion oxygen takes place to limited supply of oxygen. And that makes sense too. The limited amount of oxygen is what leads to the amount of unburned, carbon, which helps create the flame. Okay.
Okay.
And then dark zone. This is the region that is least hot. It is black in color. Right. He explained formation of vapor takes place in this region. Here, no combustion takes place. Okay. Make sense?
Yeah, that makes sense.
Okay. So just like summarize that to the best of your abilities and then keep looking at it every day until Tuesday.
Okay.
And make some flashcards on it. Do you use Quizlet?
Yeah, the teacher has us use Quizlet.
Okay, I'm gonna give you homework. I need you to show me your Quizlet every time we meet.
Okay.
Okay. All right, so now let's talk about the next one, because I also saw that he tested you on this one. Hottest part of the Bunsen burner. What do you think?
So the hottest part of the Bunsen burner is, let me just do like, so hot, not, oh, so the hottest part is like right here.
Where,
Like,
where?
like, I don't know if you can see on my, like, I'm
I did.
coloring it.
So is that
Okay.
A, B, C, or D?
Oh, that is C.
Correct. Okay, so can you explain to me why?
Okay, so it's the hottest part of the flame because they said that's where the two cones meet of the flame, and I believe one is the outer cone is the darker blue, and then the inner cone is the lighter blue, and the lighter blue is hotter because of that, the top of the lightest blue part is the hottest part.
If you
That's
had
what
to explain this, if I asked you why the hottest part of the Bunsen burner is C and explain it in 2 words, what would you say?
I would say it's complete combustion.
Yes.
Okay.
That's what I'm looking for, and that's what your teacher's looking for.
Yeah. Okay. Yeah. Oh yeah. I didn't put that. It's complete combustion when I wrote it down.
Yeah.
Okay.
So,
I should write that down.
yep, at that point, at that level, you get like the maximum degree of hotness, right? Almost at like
Yeah.
35,000 Celsius.
Yeah.
So, okay.
Okay.
All right. So the last thing here is your last page, right? And the only thing I really have on the last page, oh, this is kind of blurry. Oh no. Hmm. And okay, so that's not working. Picture correction. Oh, that's not as good either. Anyway, but I think the last thing that I wanted to show with you today is the different flame color that is associated with the compound name, right? Because I think that was one of the things that he wanted you to kind of draw up here in the last page
Yeah.
of the test, right? And he even had a question to you about like lithium salt burns with a beautiful deep red color, right? It tells you
Yeah.
he just told you it's red, right? And based on
Yeah.
color and the mathematical model above, estimate the temperature at which lithium salt burn and the voltage you would need to apply to the to dimmable light, right? And then he gave you the scale at the very top. He gave you material burn appearances. Cheeto is orange, yellow, bright. Steel wool is orange, red, and dim, and magnesium is white and what is that, blending, I'm not sure what he said there.
Blinding.
Blinding, right, exactly. So here they said lithium salt, right? And he said that it's a red, so you would already know at that point that lithium red should be around what?
It should be. It should be around like 30 that it takes to make it that color or make it to light, and then temperature for it to burn would be. I put 350 or 350 Celsius because I saw that steel wool burnt at 450 Celsius. So then I kind of just went below that because that's what I thought.
Why did you go down? Because of orange red?
Yeah, because it was orange red, and then if you wanted deep red color, you probably have to go a lower, like voltage maybe.
Hmm. It seemed like red is a higher color because Cheeto is orange, yellow, and bright.
Yeah,
So, and you know that Cheeto is at 1500. I mean, I
yeah.
think it was,
And when
at the almost there at the cusp, but I think that the safest answer would have just been like 450.
yeah, and when the teacher did go over it, they said that 350 or 450 and anything below that would have worked. And
Yeah.
then I had asked them about like 30 or less, and they said it would have been 30 or less, but I said it wrong. I should have said um 30 volts or below is what I should have said.
So that's why he blocked points.
Yeah.
Okay, well, you could have literally put a less than 30 sign and he would have to settle with that.
Yeah. It's because I think it's the reason they docked me is because the grading scale, like there's an A, B, and C, like each page is a different grade. And when you get up into like the higher, like A, you have to be more specific with everything.
Okay, all right. Well, I guess
Yeah.
for that one, just make sure you say like 30 or below or 30 or above, depending on what question they ask you.
Okay.
11B.
Yeah. So 11B, I put the deep red would mean it's hot, but not as hot as it could be. Also, it would need a lot of voltage to start it. And then they circled the a lot of they circled from of voltage to start it, and I don't really know why. And then they just put Y30 volts.
A lot of, I think when you're answering question like this, you have to be very specific. You
Yeah,
can't say a lot of, you can't say a lot like that. Because he could say that could mean 90, 120.
yeah, it can mean anything at that
It
point.
can mean anything, right? And
Yeah,
in this case, from what I'm looking at on his graph, if I'm looking at this correctly, he says that red wool is right where is this? Red is almost at, red is at 30 V, right? 30 voltage.
yeah,
The way I would answer this, just because it's like sometimes chemistry is really weird that like you have to answer things in a experimental perspective. You can say like when he asks you why 30 B, 30 voltage, you can say according to the graph above.
yeah. That
According to the graph above, on the y-axis we have color, which is orange and red. And as you go further into the axis, you can match orange red with 30 voltage. That's why I chose 30 voltage.
yeah. So they
Like
would be more
sometimes you
precise.
just have to kind of like step back and think a little bit and just be like, okay, what is he asking me? And then answer. Right? Are you guys timed when you do these tests?
Yeah, because she says that it takes her like 15 minutes to do the test. So then she like multiplies that by whatever she thinks it would take us. So we get like 45 minutes or something like that. Just depending on how long it takes her to do the test, she like just does it by 3.
15 minutes each?
Uh, well, it takes her 15 minutes. So then she's like, okay, well, they're not gonna do it in 15 minutes. So she just like 15 times 3, we'll get like 45 minutes or depending on how long the test is.
Oh, okay. Okay. So she's
Yeah.
like, I'm like, I know this lady didn't say 15 minutes.
Yeah, that would be way too short of a
Okay.
time.
Okay. So the last thing we're gonna do today, because we're coming up on an hour soon. And your parents asked to just do an hour. I know I should they want to schedule more sessions with. I'm not sure, depending on your experience today, because I think that's what they were kind of like gauging it on whenever depending on how today goes, then we'll see if we all continue with our tutoring sessions. Um, but yes, uh, we're coming up on an hour soon, and we'll that usually before I end every tutoring sessions, I like to do a review because I want to make sure that you get this right. And I know that
Yeah,
like your mom also sent me like another set of exam. I don't think we're gonna have time to go over all of those things today. We're probably gonna have to do, I don't know, maybe um I don't know when you're available again, maybe Sunday or Monday or or Sunday. I'm not sure, depending on what you guys prefer.
yeah,
Um, but in that session as well, I'll make sure to do the same thing as we do in this session, which is a PowerPoint so that you can grasp the concept pretty easily and make sure that you understand. And at the end of this, I just want to make sure, I just want to go through this very quickly to make sure for you to explain to me everything that we went over today based
okay,
on based on the exam that you have to take on Tuesday, right? So let's start off with that, the
okay.
combustion reactions, because I think it was number 3 was the question. And if I asked you again, if you were asked this question again, would you choose A and B and why? A and D and why? Because the answer are explicitly there.
Yeah. So I would choose A because um, they both produced CO2 and H2O. in both products of a combustion reaction.
Awesome. Perfect. And everything else you X'd out because,
Because they either didn't have CO2 or H2O, or they didn't have them at all.
perfect. So in number 3, there's 2 correct answers, right?
Yeah, there's 2, which would be.
Which is D, right? And you chose that for the same reasons.
Yeah,
Awesome. And then on number 4, what would you put there?
I would put water and carbon dioxide as
Ooh,
the.
congratulations. If I was your teacher, why would you, tell me why that's the case?
Two plus. Okay, so they're always formed because when you burn something, it releases carbon from within the reaction, and then water is just. I don't remember how it's the water. Water just.
Well, it's just say it releases heat, right? And water is a form of vapor, like
Yeah. Okay. So it
say,
releases heat and water is a form of vapor.
right, just say something like that, like yes, or just say that, it's water and carbon dioxide because it's how the reaction represent the release of heat or energy.
Yeah.
Okay. All right.
All right.
And so number 5, well, how would you
5.
change your answer this time?
Instead of putting carbon, I would put you need oxygen for a reactant.
Exactly. For every reaction, combustion reaction, you need oxygen, or it would not
Yeah.
work because oxygen helps create flame.
Yeah, oxygen helps the flame keep burning.
Right. Congratulations. Okay, now we did that. And then let's just tell me about this brightness of the candle deal.
Okay, so the color of the flame comes from the unburned carbon particles, which makes it yellow.
Right.
And yeah, and then
Just
the
make it
wax
yellow. And what else? So there's
and the wax is like a form of fuel.
right. And the wax is called the paraffin, right? And the form of fuel
Yeah.
is made of what?
It's made of
Hydrocarbons.
hydrocarbons. Yeah.
Hydrocarbons. And then when you explain the first one now, how would you explain that?
I
Would
would
you explain
say
how solid fuel gets to the tip of the wick? How would you explain that?
so. I would say the solid fuel melts into liquid fuel,
Mm-hmm.
then would turn it into the gas fuel, which with capillary action, it makes its way up as a vapor into the flame of the wick.
Or just write down the liquid fuel vaporizes to burn within the candle.
Vaporize. Okay.
Just use that word however way you want, because I think that's what he's looking for. Vaporize. Okay. All right. So, okay. So now you are able to answer how the solid fuel gets to the wick if he asks you again verbally, and then the yellow part of the candle if he asks you again verbally, right? And then the specifically in the candle flame, does the carbon come from that reacts with oxygen to make CO2? And you're just gonna say it's gonna come from the hydrocarbons. That is because candle wax is a mixture of hydrocarbon, right? And oxygen help the breakdown of carbon bonds.
Okay. So hydrocarbons.
Right.
Okay. And then number 4, product of incomplete combustion is it's CO2, H2O, and 2 carbon.
Right.
Okay.
Okay. And then I think the last thing we'll review here is those different type of, right, you've already talked about like the hottest part, right? You know this?
Yeah.
Can you explain why in each level? Why, like the
Okay.
explanation to why the hottest, the moderately hot, and the um least hot? I'm gonna hide those answers.
So, so the hottest part is the top of the flame where um, it's it's the outermost. How to say? It's the outermost, so that it's hottest because it's complete combustion, I believe.
Complete
At the
combustion
top,
because of what?
because of I forgot what it was.
What is the reactant?
Because of oxygen,
Yes, oxygen supply.
the oxygen supply. Okay, and then the middle zone is the region um, that is mostly yellow and is moderately hot
Right, because
because it's where the how do you say, where the wax vapor starts to burn at like right there in the middle zone.
right, and that what is that called? And the
That is that's called I forgot what it's called.
that's the incomplete,
Oh, incomplete combustion. Yeah. Okay, let me write that down.
and that's why you have unburned carbons because there's not, and you know, the oxygen supply is not as rich as the top.
Yeah. And for the dark zone, the reason is because it's least hot is no combustion happens in the blue, the bluish blackish part of the flame, and it's only where the vapor fuel forms.
Right, and that's why there's no combustion reaction because there's vapor.
Yeah.
Okay, all right, sounds like we're getting it. And then here you said it was C because of the same,
Because that's um it's because where the two cones meet, and then it's because of complete combustion.
okay, cool. All right, and then the last part was the different types of flames and the colors. And I think for this one, you know, I mean, you're gonna go into engineering, right? And
Yeah.
when you're explaining somebody's question, when it's a graph that is giving you, sometimes it helps to say things like what I said already. Just say according to the graph. Just refer to it, you know, so that your teacher can follow um, what you're trying to say. And I think he just got a little bit confused there. And if maybe you kind of um, were more specific in that, like why 30 voltage, then I think you would have gotten that point.
Yeah.
So in that case, that's where we're going to end today. I hope that that was helpful, and I hope that it helped you kind of understand the concepts that you needed a little bit more help on that test. I'm hoping that we can meet again. Um, so I'm not sure if your parents are around or yeah, or maybe I'll just communicate with them.
How you doing? I'm his dad, Matthew. We
Hi,
spoke last night.
Hi, Matthew. How are you? Thank you for
Good, I'm
reaching out
good.
to me.
Most definitely. Thank you for helping us. My wife is here as well.
Hi.
We were
Hi,
trying to cut her off.
Priscilla.
Hi, nice to meet you.
Nice to meet
So
you.
it sounds like Nice meeting you also. It sounds like everything went well, and you were asking him some pretty good questions and kind of guiding him through it. So if you're available Sunday, we could meet Sunday.
Yeah, so yeah, that would be fine. Just let me know what time. And today we were only able to do test one, and we kind of went over
Right.
that thoroughly so that he understands well. And I think what he
Okay.
can do is just review that and keep looking at it until we meet again Sunday to go over test two.
Okay, sounds good. We're available anytime Sunday, so whatever open spot you may have, that will work for us.
Okay, so I usually after like 5 p.m. I'm
Oh,
available.
that's right.
Oh, yeah. That's right.
Okay, we can do 6. Give you enough time to
Yeah,
get home and get adjusted.
that's awesome. So let's do, I'll write that out and then I'll just send the calendar invite again like last time. 6 p.m.
Okay, perfect.
And then we'll go over the test two. Okay. I'll
Okay,
send you
sounds
guys
good.
Venmo account and everything, so you have that.
Okay,
If that works for
Perfect.
you guys, right? No?
yeah, Venmo's good. We can do
Okay.
Venmo.
Cool. All right, well, thanks again. Devin, I hope this test goes well for you on Tuesday. If you have any questions, I will give you my email right here where you can reach me if you have any questions. If
Thank
Okay.
you. We appreciate it. I hope it goes good for him too, because he really needs it. I
another,
mean, he's got it, like the rhythm of it, but he just I think gets a little lost in trying to explain it.
yeah, I think as long as the name of the game is practice.
Right. Yeah.
And as long as, like I said, repetition is important, like all the concepts that we went over today, it'll be important for him to just look at that, because I think he gets it now, because we went over every question on that test and he can explain it.
Right.
So
Okay. That sounds good.
yeah, I think
So
it's,
then we will. Go ahead. Sorry.
yeah, keep going, sorry.
No, I was just gonna say.
Some of the things that I was hearing, like when you guys were doing this, a little bit off the side, I heard you say something, because I had the same concern about some of the questions seemed like he should have gotten it right. But do you think that the reason why they marked him simply because he didn't have enough detail to the answer? But do you think it looked right on your, like from what you saw?
Well, I mean, some of the answers were not complete. That's what I will say.
Oh, got it.
Yeah.
Okay.
Yeah, there were just like one part of it was complete, but there was some explanation that needed to be explained just a little bit more. So I can see how he got like maybe half a point in that. And so we talked about those, what the teacher was looking for in terms of an explanation for those parts as well.
Yeah, I try to tell him, after he's done reading it to go and answering it, to go over and read the question again and make sure his 2 parts to the question or 3 parts to the question is all answered correctly. I think that's the big problem, is he doesn't completely answer the question. He reads it, but he'll answer the first part or the middle part and not the last part.
Or he'll answer too fast and he won't finish reading the other options. Because like last night we were going over some of the stuff and there was 4 questions, and by the time my wife was reading the second one, he was already saying that's the answer. And I said, you got to listen to all your options, because there might be something slightly off.
Yeah.
Yeah, and that just takes practice too. Trust me, I've been there. Sometimes we want to move fast because we don't have enough time. And I think that's just a time management too when he's taking an exam. So another thing that I would recommend, I don't know if you're taking this exam online or if this is a paper test. One of the things that helps me kind of make sure that I'm seeing the detail, literally, I will circle the word. I would be like what I said, like this question right here, Devin, if I'm trying not to miss something, I'd be like, I'll circle solid fuel. I need to focus on this. I need to focus on the tip of it, because sometimes you get lost in like that question when you really need to circle something. I'll show you even more, right? Because you're gonna, as you kind of grow in academic and you go into engineering or whatever, field you go into, you're gonna have to, be more specific with the way that you, sorry, what's happening here? The way that you review questions. And I'm just gonna show you an example because you're in 10th grade, right? And you're gonna probably take, what you call this, SAT soon, right? So this is just a test strategy that I'm gonna show you really quickly because I go through this as a medical student and my life is to take exams. And you're gonna have to do this, especially if you wanna go into engineering. I'll just show you really quickly. So this is some of the things and another thing about taking exams, Devin, is that, you don't have to get, when you're practicing exam, obviously you don't have to get everything correct. But the thing about it is learning from what happened, right? So for me, I have to highlight things like this to make sure that I'm like following what is being asked of me. I'm like, okay, sorry, this is medical stuff, but like, okay, you're doing chemistry and you're focusing on solid fuel and the yellow flame. If you have to highlight yellow flame because that is what he's asking you. Sometimes you have to step back and just say, what is the question asking me? Because sometimes you can have your first interpretation of like, oh, he's asking me this. But then that's your fast response. Okay.
Yeah.
Sometimes you just have to get to step and not just think of it in that way. Just step back and be like, what is it asking me? But what is the professor needing from me? Because that's ultimately what he's asking for. You not that you have to think like the professor, but just think about what is he really asking me? Okay. And I think we talked about that when he came to the first exam, right? The last page of the exam, when he kind of docked you for that graph, right? And I told you, like, as of now, when you start taking exams, you have to kind of think of things scientifically because this is chemistry, right? When you're looking at a graph, you have to say, according to the graph above, you have to be specific. Like saying a lot of voltage is not appropriate anymore. You have to say, according to the graph above, orange red corresponds with 30 voltage. And you can like show that. You can literally like, show him and just like put double that and then go down. And then explain that in your words in 11A or 11C so that he can understand like why 30V. I think it's 30V because this is how I did that. And then, if he decides to deduct points, he can't deduct that much point because you've explained your thoughts.
Yeah.
So I think
the grading system it's a different, they just adopted something new. Matt, what was it called? Do you remember? It's like a grading curve with this, and basically his school is the first school that's going to be trying it out.
mm-hmm.
So it's just really odd how they're, because if this was last year, I think he would have gotten probably not like a really good grade, but he probably would have got like a B, C, C, D, they're just deducting way too much, and her scoring is 80% of the grade. So his tests are a lot.
I see. So no, I get that, you know. I mean, I don't, I want to say, what do I want to say? I want to say, um, it's tough that they're doing this, but I think that
Yeah.
they're doing that because that's how universities are.
Right.
That
Yeah, and that, I think that's what they're preparing them for too.
yeah, like, you know, for me, as I, you know, complete my doctorate, the way that they score things is the same way. It's always, the weighted scale is always very high.
Yeah, exactly.
And so
Well,
it's good to start kind of learning that now at a very early stage, so that when you get to those like levels of academia, you won't struggle so much.
yeah. Yeah, it will benefit him in the long run. So we
Yeah.
just have to, you know, keep him in the tutoring sessions and just get the help he needs.
Yeah. And you know,
Right.
if you don't make it, sometimes it's okay. You have to keep reviewing that. Like, this is perfect what we did. We reviewed everything. So the next time you take this test, you'll do it well.
Yeah.
Right. Okay. Well, thank you so much. I appreciate it. And we will meet with you on Sunday. We'll use the same link.
Yes, I'll send the calendar
Okay.
invites and everything, and then I'm not sure if I should text Matthew my Venmo information or email it to you or whatever works
You
best.
can text it to my phone. I have the Venmo account, so I can just
Okay.
like click
Your
on it
number.
and it will just take it to the Venmo.
What's your number?
It's 650
Okay.
288
Mm-hmm.
2438.
2438.
Yeah.
288-2438. And I'll just save you here. Okay. All right. Sounds
Okay.
great, guys.
Thank you so
If you have
much.
any question, Devin, feel free to email me and keep reviewing what we reviewed today.
Okay.
Words.
All right.
Thank you.
Thanks. Have a good weekend. We'll see you Sunday.
You too. Take care. Bye-bye.